Hello and welcome you all to this lecture. Here we will be discussing application of second order differential equation. In the last video we have started this topic. One question we covered, so you can refer to that last lecture of this particular playlist. But prior to that, I'm going to solve one question which was a query from few of my students related to the solution of this equation, that is solve 3y plus 4xy square dx plus 2x plus 3x square y dy. This was the question. Now you can pause the video and try yourself so that you get an idea whether it is solvable or not by the usual methods. Okay, so you can pause this video and try this question. Now see, let me solve this question for you. So this equation, it is of the form m dx plus n dy is equals to 0. So whenever you have this type of equation, immediately you should check whether it is exact or not, that is del m del y is equals to del n del x or not. This thing you need to check. So if you check this quantity, that is del m del y and del n del x, they are not equal. So in this case they are not equal. So basically they are not equal means this equation, it is not exact. Okay, so it is not exact. Moreover, this equation, if you just see, they are nothing but polynomial, but they are not of same degree, so you cannot claim that it is homogeneous. So it is not exact, not homogeneous. Okay, not homogeneous. So in such cases, what you need to do, see, this is the most general treatment one can adopt, that is, this equation, it is not exact, but you can make this equation exact by multiplying some factor, okay, or multiplying some term, that is known as integrating factor. So let integrating factor is x power m y power n. Okay, I'm considering the general case, that is x power m y power n. This will be integrating factor. So if you multiply this term with this equation, so this equation is 1, if you multiply this term with 1, then 1 will become, so 1 will become, if you multiply, so what you have, x power m y power n, here 3y plus 4x y square dx plus x power m y power n 2x plus 3x square y dy is equal with 0. Okay, so if you just do further calculation, you will be getting 3x power m y power n plus 1 plus 4x power m plus 1 y power n plus 2 dx plus 2x power m plus 1 y power n plus 3 x power m plus 2 y power n plus 1 dy is equals to 0. Now see, as you have multiplied the integrating factor, then this equation must be exact. This equation must be exact. So for this equation, this term, see this term, it is your new m, and this term, it is your new n. So in this case, what you have, see, del m del x, it should be equal with del n del y. So del n del x, you can find del n del x, it is given by 3, obviously del m del y, and del n del x you need to find. So 3 n plus 1 x power m y power n plus 4 n plus 2 x power m plus 1 y power n plus 1. and del n del x, if you find this one del n del x, this is your n, so 2 times m plus 1 x power m y power n plus 3 m plus 2 x power m plus 1 y power n plus 1. Now see this setup, del m del y, it should be equal with del n del x. Alright, so if you just compare both the terms, so immediately this should be equal with this and this one should be equal with this one. Okay, so that implies 3 n plus 1 is equal with 2 m plus 1 and 4 n plus 2, that is equal with 3 m plus 2. Okay, so here if you just want to solve this equation, so in that case a simple technique, that is 3n minus 2m, that equal with minus 1, and here you have 4n minus 3m, that is here 8 minus 2. So now you solve these two equation, that here you multiply this equation by 2, this equation by 3, then subtract. So 6n minus 4, sorry, multiply this equation by 3, here by 2, so 9n minus 6m, and here you have 8n minus 6m, and here minus 3 plus, but you have 4. Okay, so here you are getting n is equal with 1, and similarly if you just put n equals to 1 here, so what you got, see 3 into 2, 2 into m plus 1, that is from here m is equals to 2, so n equals to 1 and m equals to 2 you are going to get. So finally the integrating factor is x power m y power n. Okay, so this is going to be the integrating factor. Now once you have this integrating factor, then this equation what you already claimed as exact, just write down that equation. So that equation is 3x square y square plus 4x power 3 y power 3, I guess this one, yes, dx plus 2 x power 3 y power 1 plus 3 x power 4 y power 2 dy is equals to 0. If you just take, see, x square y common, immediately you will be getting that previous term. Okay, just see. So this term you are going to get if you just take x square y common. So basically x square y is your integrating factor. Now this equation, it is nothing but exact equation. Okay, so the solution of this equation, it is given by integration of m dx, treating y as constant, plus term in n not containing x, dy is equals to c. So if you just do this integration, m is 3x square y square plus 4x cube y cube I think, see, x cube, yes, correct. Okay, fine, dx plus term in n not containing x, so basically no term containing all the terms. See, here you have x, here you have x also, so no term without x. So if you solve this one, integrate this properly, so 3 x cube by 3 y square plus 4 x power 4 by 4 y cube equals to c. So the final answer should be x cube y square plus x power 4 y cube equals to c. Okay, so this will be the solution for given equation. So it is little bit tricky, but this method you can apply for any equation whenever this exact form or this homogeneous form it is not satisfied. So immediately you can make this equation exact by adopting a new integrating factor, and once you have that, after that immediately you can apply this last formula and you will get the solution. Okay, I think it is clear. So similar type of question you can practice. Now we are moving to this application part. So application, here you have, see, one question from LCR circuit related to damping, over damping, under damping and critically damping case. So we studied that one. Okay, you can refer to the last lecture. Now I am moving to the next part of application, that is vertical motion. Okay, rectilinear, under rectilinear motion, one of the important part it is vertical motion, and we have a very important application of second order differential equation. So vertical motion. Okay, so vertical motion, one question you can take. First question, a body falling vertically under gravity encounters resistance of the atmosphere if the resistance varies as velocity, if the resistance varies as the velocity, then show that the relation between the distance that is x and distance fallen, that is x, and time t is x is equals to gt by k minus g by k square 1 minus e power minus k t. This is the question where k is constant, Okay, so this is our question. So if you just consider the solution here, see, a particle, it is moving vertically. Okay, so always mg is there. Suppose the mass it is m, so always mg is acting on this particle. So against this, but you have the resistance of the atmosphere, resistance of the air, and resistance varies as the velocity. Okay, so resistance, that is, if you consider resistance varies with the velocity, so was K U multiplied with M. Okay, this is the resistance we have. Okay, so the as per the Newton's law, what you have, F is equals to mg minus mku. Okay, so where u is velocity of that particle. Okay, now this f can be written as m into du dt, that is equal with mg minus mku. So from where you got this k concept? See, this resistance, suppose resistance, it is suppose f. Okay, f1. Okay, it varies with u. Okay, so f1, it is nothing but ku for unit mass, now the mass, it is here m, so what you have, m ku. Okay, so from here you are going to get du dt as g minus ku. So this is nothing but equation of motion. This is equation of motion. All right, so here you have equation of motion. Now this equation, you can directly consider this equation, and this is nothing but du dt plus ku is equals to g. So here integrating factor, that is e power kt. So here we have started the solution. So e power kt integrating factor, so u is equals to u multiplied with e power kt, that is integral, here you have g, so g into e power kt dt. All right, so if you further do the calculation, g e power kt by k plus c, so here what you have, u e power kt, that is g e power kt by k plus c. Now see, the particle, it starts from rest. Okay, initially it was at rest, so at t equals to 0, u is also 0, so initially it is 0, so 0 is equals to g by k plus c, that is c is equals to minus g by k. Now from this equation, what you are going to get, u e power kt, that is g e power kt by k minus g by k. So from here u is equals to g by k, you can take common, 1 minus e power minus kt, this thing you are getting. Okay, now see, further your target is to get the relation between x and t, so u is nothing but dx dt, so g k 1 minus e power minus k t. So now separable variable method we can apply, and g by k, here integration 1 minus e power minus k t dt. Okay, so here x is equals to g by k, here t minus e power minus kt by minus k, so here you have k plus c1. Okay, so here you can see again c1 is the constant, so you need to apply the conditions. So t equals to 0, initially the distance travel, it is also 0, initially it was here, here, so no distance traveled. So from here immediately if you put, you are getting g by k 0 plus 1 by k plus c1. So here you are getting c1 equals to minus g by k square. So back substitution here will give you x is equals to g by k t plus e power minus kt by k minus g by k square. Now last two terms, if you just take these last two terms and gt by k here and take g by k square common, then immediately you are going to get this relationship. Okay, so this is the expression we were supposed to get. So finally we got this relation which is within x and t. So this is one of the standard type of problem. That means here we need to consider the scenario, and after that equation of motion, in most of the cases equation of motion will be given. If it is given, then okay, otherwise you have to construct like this, then solve as per the methods whatever we have discussed, and immediately you will get the final conclusion. So this type of question you should practice from vertical motion.